All right, hello. My name is Putra Picoso, and this is my video exam. One of the options that I picked today was the moss life cycle. So starting from number one, the spores are being dispersed right over here from the peristome, which is at the tip of the capsule of a mature sporophyte. And these spores can go through two different life cycles, one being the male gametophyte and another one being the female gametophyte. So in this male gametophyte, it'll grow into an antheridium, and through mitosis, the antheridium can produce sperm. Through the female life cycle, this can grow into an archegonium, and in this archegonium, there's a little egg at the bottom of the archegonium, and that's where the sperm will eventually be to fertilize it into a zygote. So moss is very heavily reliant on water when it comes to reproduction and transport of the sperm, and it'll usually come in a form of a raindrop, like so right here. And so how it usually works is that the raindrop or with the sperm in it, it'll usually start right over here, all that sperm, and then they'll climb up the archegonium and then eventually go to the top of the archegonium and go down and then fertilize the egg that's over there. And then it'll eventually turn into a zygote right over here. And then it'll turn into a nice little embryo. And then eventually it'll turn into a young spore. And it's not completely sprouted yet, it's still encased. And right after being a young spore, it'll be a mature sporophyte. Sorry, not a young spore, it's a young sporophyte. I'm so sorry. Yeah, and in the mature sporophyte, it consists of the seta that's right over here, and right over here is the capsule. And in the capsule, there is also the sporangium, and the sporangium through meiosis can create spores and will eventually disperse, and then it brings us back to the beginning of the moss life cycle. Cool, right? So what we're looking at here is a picture of little mature moss sporophytes. These are really super tiny, so tiny. It was really hard for me to find one myself when we were looking through it in the microscope, or even looking for one inside the moss mass. So it was crazy. Right over here, though, is the seta, and right over here is the capsule, which contains all of the sporangium and all of the spores that will eventually disperse, break open, such like this right here, will eventually break open and disperse, creating either the archegonium or the antheridium. And finally, we're going to be looking at tissues, the permanent tissues in angiosperm stems. I said that in two different words. So as you can tell, these are two very different stems, and they look pretty, different, right? Yeah. So on the left is the dicot stem, and on the right is the monocot stem. So in the dicot stem, as you can see, that there are little sections or layers to the tissues, whereas on the monocot stem, it's just a whole bunch of tissues that are just dispersed throughout the whole stem. And that's pretty much like how you can tell between the two. And the thing about these two stems is that they also have the same functionalities, the same tissues, it's just placed differently. So one of the tissues that they have is the epidermis. That epidermis is just the protection for the plant, protection of the stem. The next one is the cortex and the pith. I say these two together because they have pretty much the same cells, which function in nutrient storage. So that's pretty cool. And in the monocot stem, the ground tissue also has cells in which provide nutrient storage as well in the ground tissue. The next thing is the vascular bundles. As you can see on the monocot stem, they're significantly smaller, and they do have a shell around it, or like a little dark outline around it, which is the bundle sheath, and it's closed. So it's just this first, but they still have a xylem and a phloem in them. It's just very small, closed off in the bundle sheath. In the dicot stem right over here, as you can tell, it's open. There's no bundle sheath closing it, and it's significantly bigger. And like I said previously, in these vascular bundles, there's the xylem, which is responsible for circulating water from the roots through the plant, and the phloem, which is responsible for circulating the food that's made from the leaves. But yeah, and the thing about this is that dicot stems are actually much easier to cut in terms of trying to make fruit grow bigger, which is pretty cool to me. And I thought it was awesome. I actually didn't know that until this class. So yeah, this is the entirety of my video. Thank you for watching, and I hope that I did well. You have a great weekend. Yeah, thank you.